In this video, we are going to study linear regression, residual standard error in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding packages. Therefore, we comment this as step 1, which is packages. And for this video, we're going to import numpy as MP. We're importing numpy for square root calculation. Then we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.formula.api as SMF. We're importing that feature from statsModels for multiple linear regression calculation. To run these code lines, we go ahead, select them, and then we can either click Run Selection button or press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named house prices underscore object, which is equal to SM feature from statsModels.datasets .get underscore r dataset, and we open parentheses. First parameter, which is data name, equals to, and within quotations we have house prices, comma, and we continue the following row, package, equals to, and within quotations AER, comma, cache, equals to true. So what we're doing here is the following. We're downloading house prices object from our package AER, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within house prices object. Therefore, we're going to create a new object named house prices with only the data. Therefore equals to, and from the house prices underscore object, we're going to get its .data attribute. So to run these code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And if we go into the variable explorer, we see the two objects being created, house prices object with data and documentation, and then we have house prices with only the data. So if we double click on any of the cells from the one with only the data, we can see the corresponding data. So in this video, we're going to focus on the first 3 columns of data of price, lot size, and bedrooms. And the reason for this is that we're going to fit a multiple linear regression in which price is the dependent or explained variable, which has been explained by the independent or explanatory variables of lot size and bedrooms. If you have any questions regarding this data, you can print its documentation with the following code line, which is print, open parenthesis, and we have house prices underscore object, and we're going to get its dot 2 underscores doc 2 underscores attribute, and as it is a single code line, we select any part of it and we directly press F9 on the keyboard, and we'll see the documentation being printed within the console. So we scroll up, and there we have house prices are documentation. So now we continue with step number 3, which is the model. For this, we're going to create an object named MLR, which stands for multiple linear regression, which is equal to, we'll be using SMF feature from statsModels.ols or in our least squares function, and the following parameters, which are formula equals to, and within quotations, because this is a string, we have price as a dependent or explained variable. This special character means being explained by the independent or explanatory variables of lot size plus bedrooms, comma, and we continue at the following row, data equals to the house prices object that we created above, and we go ahead and fit this regression, open and close parentheses. So to run these code lines, we go ahead and select them, and then we go ahead and press F9 on the keyboard. And now we're going to continue with step number 4, which are the results from this regression. And we're going to print specifically the residual standard error. So we do so with the following code line, which is print, and within parentheses we have mp, which is numpy dot square root, and within parentheses we have from the MLR object we're going to get its dot mse underscore resid attribute. So this corresponding residual standard error is a goodness of fit metric for the multiple linear regression, which is equal to the square root of the residual's mean square error, which is the calculation we have there. So as it is a single code line, we're going to directly press F9 on the keyboard, and we can see the result being printed within the console. And we also want to do the calculation manually, therefore we have also with print function, and again numpy dot square root, and we're going to calculate manually that mean square error of the residuals. Therefore we have first the sum, and within parentheses from the MLR object we're going to get its residuals resid, those to the power of 2, and that result is divided by, and from the MLR object we're going to get its dot df underscore resid, or the residual's degrees of freedom. So as mentioned previously, we have that the residual standard error is equal to the square root of the mean square error of the residuals, which by itself is equal to the sum of those residuals to the power of 2 divided by the degrees of freedom of the residuals. So let's go ahead and run this code line by pressing F9 on the keyboard directly, and we can see the results being printed. So specifically here we have the manual calculation, which we can compare with the calculation we did above, which is an equivalent calculation. Okay, so with this we finish with the code file, so we can go ahead and save it. And with this we also finish with this video. Thank you for watching.